from red bauxite. From red bauxite. We have two methods. One is Bayer's, the other is Hall's. Bayer's process, Hall's process. In Bayer's process, the bauxite ore, Al2O3, 2H2O, this is bauxite. Plus, what is the impurity? Fe2O3 impurity. It is heated with NaOH at 150 degrees centigrade. So we will get soluble sodium meta-aluminate. Sodium meta-aluminate. Plus Fe2O3 insoluble. So when it is fused or melted with NaOH at 150 degrees centigrade, this Al2O3, because of its dash nature, it is soluble in NaOH. Very good. Because of its amphoteric nature. Actually, aluminum oxide is a basic oxide. Base should not be soluble in a base. But Al2O3 is an amphoteric oxide. That's why it is soluble in NaOH to form sodium meta-aluminate. This remains insoluble. This is removed by filtration. This is all step 1. Now in step 2, the sodium meta-aluminate is subjected to hydrolysis. You will get aluminum hydroxide, precipitate, plus NaOH. This is step 2. In the final step, this aluminum hydroxide is subjected to strong heating. You will get Al2O3 plus H2. 2 ALOH thrice, 3 H2O, it is balanced. So this is pure, free from impurity. It is free from impurity. This pure alumina, it is called alumina. This is Bayer's process. In Hall's process, same bauxite is fused with sodium carbonate plus Na2CO3. Again you will get sodium meta-aluminate plus CO2 plus H2O. This is soluble. Who will remain insoluble here again? Fe2O3, insoluble. How insoluble can be separated? By filtration. This is step 1. Step 2. Same, the sodium metaluminate subjected to hydrolysis, but in the presence of carbon dioxide. Again, you will get aluminum hydroxide as a precipitate, plus sodium carbonate is recovered and again used in the first step. The last step, third step, is common here. Same as in Bayer's process. This is how to remove impurity from bauxite. So bauxite is the most abundant ore in the earth crust, and aluminum can be profitably recovered from bauxite. Actually, when Hall discovered this process, aluminum production became so much in the entire world, and aluminum is used everywhere for wrapping your food materials, aluminum pouches, aluminum wires for electrical power linings, aluminum sheets, metal sheets in cinema shootings and indoor photographies. They are good reflectors. So aluminum has a lot of use, chocolate wrappers, cigarette wrappers. Aluminum is so widely used nowadays. Not only that, aluminum partitions, aluminum, this is aluminum. This smart board, this entire frame is aluminum. So aluminum is so widely used because of Hall's process that becomes so cheap in producing aluminum. But in Bayer's and Hall's, we have not produced aluminum, we have just removed the impurity. And what is the final product in Bayer's and Hall's? Pure Al2O3 called alumina. This is the end product here. Now I am going for one more process, Serpex process, to remove SiO2 impurity. To remove SiO2 impurity, from white bauxite Serpex process. Now in this, the bauxite ore is fused with coke in the presence of nitrogen. These, all the three are strongly heated. What is the impurity present here? SiO2 impurity. So when all these together heated, first the SiO2 impurity react with coke and form silicon and carbon monoxide. So impurity is converted into carbon monoxide plus silicon. When I write the arrow upwards, they are escaping as volatile gases. Impurity is gone. Now Al2O3 of the bauxite react with coke and the presence of nitrogen. to form aluminum nitride plus 3CO. So this is all step 1. Step 2. Aluminum nitride is subjected to hydrolysis to form aluminum hydroxide plus ammonia. The last step, same as in Bayer's and Hall's processes. The aluminum hydroxide is strongly heated to get alumina plus water. This is Serpex. What we have removed here? SiO2 impurities removed. In the Bayer's and Hall's process, we removed a Fe2O3 impurity. In Bayer's process, to remove a Fe2O3 impurity, we used NaOH. In Hall's process, to remove ferric oxide impurity, we used sodium carbonate. Here the silica impurity is escaped in the form of silicon plus carbon monoxide. It is first reduced. Now, once the ore is purified or the impurities removed, now we are going for how to extract aluminium. That I am going for. Can I move to the next? So, extraction of aluminium by Hall-Heroldt's process. Hall-Heroldt's process. Actual alumina, Al2O3, is a bad conductor of electricity. Al2O3 is a bad conductor of electricity. Now, how this convert into good conductor? To make it better conducting, it is fused with cryolite 3NAF dot ALF3. This I think already in the NEET JE almost 3 times this question was asked. The purpose of adding cryolite in Hall-Herold process, because in Hall-Herold process electrolyte is Al2O3, that is alumina, which is a bad conductor. That's why we make it a better conducting by fusing with cryolite. Cryolite is RNA3ALF6. Both are same. Now, so the electrolyte is a fused mass of cryolite plus bauxite. What is meant by fused mass? Molten mass. Now cathode. Cathode is gas carbon. Now anode is graphite. Now this is the setup actually. The entire setup is, because aluminum extraction we don't do in a small lab scale, huge. In India we have two big aluminum companies, both are owned by the government of India. One is National Aluminum Company Limited. We call it as a NALCO, NALCO. The other is Bharat Aluminum Company Limited, BALCO. This NALCO and BALCO are the main producers of aluminum for our country. Both are situated in Odisha state. Maybe the bauxite ore is more there. Or surrounding areas, you have more bauxite. Because transportation of ore is also a big issue. Generally they choose, wherever the ore is available, they set up the factory there. Otherwise transportation becomes too difficult, because the iron ore is present in, again, Kirandal in Odisha. But steel factory, Vizag steel factory is located in Andhra Pradesh. Ore is present in Odisha state. So from Odisha to every day, the iron ore has to come to Vizag. So government of India asked the help of Japanese government. So Japanese constructed a railway line on the Eastern Ghats. A train goes on the mountain tops by tunnels, through tunnels. Highest number of tunnels are present in that route, because when you cross one peak, you will get another peak, again one tunnel. So train passes through the tunnels and brings the ore to Vizag port, where it is subjected to blast furnace, Fe2O3 reduction to get iron. That iron is converted into steel. That is India's one of the famous brand of steel, Vizag steel. It is also owned by government of India. One more, you have Kudremukh iron ore project in Karnataka state, Kudremukh, where the iron ore is again present Fe2O3, hematite, and Fe3O4, magnetite. You have two important iron ores, hematite, magnetite. Now these two ores has to bring to the Mangalore. So again the government of India asked Japanese help. Now Japanese government, this time they did not construct a railway line, but constructed a pipeline. So the iron ore is crushed into small pieces, mixed with water. Under pressure, these small pieces of iron and water is pushed to Mangalore. From Kudremukh to Mangalore, the iron ore comes, where it is getting filtered, water is removed, and it is shipped and exported to different countries. So different ores are available depending on the geographical conditions at different places on the earth crust. So it all depends on the nature of the soil, earth, the earth formation and all these things. Why a particular ore is present at a particular place. For example, in Rajasthan you have copper mines called K3. K3 copper mines is very famous. Like that, manganese is present, mica is present in Andhra Pradesh. Many different places, different ores are available. Of course, uranium ore is also present in Andhra Pradesh. But when the government want to excavate and remove extract it, the ore, people are worried because it is uranium ore, radioactivity. So all the surrounding areas will be affected by radioactivity. That's why now the government has started its functioning. For the last 1 week, people are protesting, Rasta Roko, Rail Roko, this, that. Many things are happening. So it all due to their fear. Maybe the fear may be true or false, we don't know. If it is that much radioactive, they will take protective measures to dig it out and take it to convert into uranium-235. So, in the extraction of aluminum by Hall-Heroult process, it is an electrolytic process. An electrolyte should be always a conducting electrolyte. But by Bayer's, Hall's or Serpek's process, we got pure ore, Al2O3, called alumina, which is not a conductor of electricity. Thus it is melted with cryolite and taken as electrolyte in a big containers. The cathode is a allotrope of carbon called gas carbon. This gas carbon lining acts as a cathode and C graphite act as anode. Now on passing electric current, the electrode reactions. So electrode reactions in Hall-Heroult process. So in Hall-Heroult's process, what happens is AlF3 from cryolite first ionizes into Al3 plus 3F minus. Because Al2O3 is a bad conductor of electricity, that won't ionize. Now this Al3 plus takes 3 electrons and convert into aluminum. This is reduction. Addition of electrons is called reduction. Reduction always occurs at cathode. Reduction occurs at cathode. Now the F minus ions, they go to the anode and lose their negative charge and convert into fluorine gas. This is oxidation, loss of electrons. This occurs at cathode. This occurs at anode. Cathodic reduction, anodic oxidation. But fluorine is highly reactive. We already discussed this point. It is the most reactive non-metal in the periodic table. Now this highly reactive fluorine attacks the alumina because it is lying waste, though it is the main source. The fluorine reacts with alumina to form aluminum fluoride plus oxygen. So this aluminum fluoride again goes to the first step. Initially, first aluminum fluoride comes from cryolite, but later in the reaction itself, AlF3 is produced by the reaction of fluorine with aluminum, with alumina. So write this 4AlF3, 6F2, 2Al2O3, 3O. This is a balanced equation. Or you can also balance. Now, the oxygen liberated, it attacks the anodes, carbon anode, plus oxygen gives carbon monoxide and carbon dioxide. So 2CO, 2O2, 3C. All are extremely important. Yes, because in one JEE exam, they asked how many moles of oxygen is evolved in Hall-Heroult process when 2 moles of fluorine reacts. For 6 moles, how many moles? 3 moles. 2 moles, how much? Easy only, but you should know the step. 6 moles is giving how many moles? 3 moles. If it is 2 moles, how much? 2 into 3 by 6. How much? 1 mole. That is the answer. Not a difficult question. They want to check your alertness in the entire subject. Write a note here. To prevent the oxidation of carbon at anode, powdered coke is spread on the molten electrolyte so that the liberated oxygen reacts with the powdered form more easily. Actually, when compared to solid form, powdered forms are always more reactive. This is Hall-Heroult process. Now, regarding the properties of aluminium, it burns in air to form Al2O3 plus aluminum nitride. But this reaction is highly exothermic. Delta H is equal to minus 772 kilocalorie per mole. Oh. Today heavy food in mess. Breakfast. Many students are sleeping. You are already habituated to the schedule. So your bio clock should act accordingly. Okay, listen. Actually, this reaction, burning of aluminum in air, giving both aluminum oxide and aluminum nitride, is a highly exothermic reaction. Delta H I wrote negative. Now this makes or this is the root cause when Bin Laden attack on World Trade Organization with the 2 small fighter planes two small passenger planes which were hijacked. And it is a tall tower. Two planes just rammed into one of the floors of the tall towers, vertical towers of the World Trade Organization. So the American engineers, while constructing these long towers, they calculated if at all, if any accidentally a plane hits the tower, what would be the damage? They already calculated all these and constructed accordingly. But very interestingly, just they have not put any explosives. A plane rammed into the floor. It bursted into flames. The fuel only spilled. So according to engineering, only that floor or the above floor should have some damage. But very interestingly, both the towers totally collapsed. So it is a very perplexing situation for the American engineers. The Congress asked to explain without explosives how the entire tower collapsed with a lot of people in that. Almost more than 10,000 people died. So America says 10,000 people are missing even today. It occurred long ago. So there is a different political issue. So finally what they understand was, after thorough research, they found that each floor of the building had so many aluminum partitions. Like if you go to a computer center, you have some partitions, cubicles made with aluminum. So aluminum is lightweight and easily molded. So each building offices fully furnished with aluminum. So in one floor, the aluminum caught fire and burned, produced huge energy, exothermic. That makes the aluminum to burn in the another floor. That also caught fire. And like that, it occurs as a chain reaction. In every floor, the aluminum burned and caused huge heat that is responsible for the overall collapse of the big structure. So aluminum fires are very dangerous. So it is a highly exothermic reaction. Aluminum, though it is a metal, it reacts with NaOH and forms sodium aluminate. It is called sodium aluminate. It also reacts with NaOH in the presence of water, aqueous. Here pure NaOH, here aqueous NaOH. You will get sodium meta-aluminate. Here one important question is there regarding this. Aluminate ion can be represented as AlH2O 6 times 3 plus. AlH2O 6 times 3 plus. Similarly, meta-aluminate is represented as AlOH 4 times 2H2O minus. Without knowing this point, you can't answer this question. Please write the question. The coordination number of aluminium in both meta-aluminate and aluminate. In both meta-aluminate and aluminate is dash. Within the square bracket, when a metal is surrounded by some ions or molecules, so that is called coordination number. Here 6 water molecules are surrounding the aluminium. So coordination number is 6 here. Here 4 hydroxy ions, 2 water molecules. So total how many? 6. So both in aluminate and meta-aluminate, the coordination number is 6. This point you can answer, we already discussed this. With concentrated nitric acid, what is the reaction of aluminium? Is it aluminum oxide or aluminum nitrate plus oxygen, or aluminum nitrate plus H2? So what are the expected products? Aluminum plus concentrated HNO3. Anyone? Answer: no action because of protective oxide layer formation. This is called passivity. So aluminum, concentrated HNO3 do not react with each other. Why? Due to the formation of a protective oxide layer. So here I am writing no action due to protective Al2O3 layer. So aluminum Cr2O3 plus aluminum, Fe2O3 plus aluminum, Mn3O4 plus aluminum. So in all these processes, aluminum acts as a reducing agent. This is called thermit welding. Thermit welding or Goldsmith aluminothermy process. So here you will get Al2O3 plus Cr. Here Al2O3 plus so Al2O3 plus Fe. Here also Al2O3 plus manganese. In thermit welding, aluminum acts as a reducing agent. How can you say it is a reducing agent? 0 to plus 3. It is undergoing oxidation. When it is undergoing oxidation, it acts as a reducing agent. Write another point. Thermit welding is a highly exothermic process Dermit welding is a highly exothermic process. It's a highly exothermic process, and the metal formed will be in the molten state and is directly used for welding or welding purposes. Directly used for welding purposes. So this is about the important properties of aluminium. So with other acids it reacts. For example, you treat aluminum with HCl, it reacts, forming AlCl3 plus H2. Now, what are the uses of aluminum? Just now I mentioned. It is used as a reducing agent, used for making electrical wires, electrical conducting cable wires. Aluminum reflectors are used in indoor photography, for wrapping the food materials. Actually, aluminum vessels are also used earlier, or the alloyed aluminum vessels, like pressure cookers and all. But the problem was, an American doctor discovered the aluminum, more the aluminum content goes into your body. Of course, kidneys excrete aluminum. In some cases, when kidneys could not do the job, the aluminum will be deposited in the brain. That causes loss of memory and muscle coordination. That is called Alzheimer's disease. So one of the potential reasons for Alzheimer's disease was due to aluminum accumulation in the brain. Thus now it is recommended not to use aluminum vessels or vessels alloyed with aluminum. So the American Food and Safety Department advises to the world, nowadays only you can use stainless steel vessels or cast iron vessels. These are the best vessels used to cook the food, not any other. Teflon coated aluminum vessels or anodized aluminum, many are available in the market, but all will cause damage to your health. Best two metals will be used for cooking, or best used for cooking will be cast iron or stainless steel. Now we go to the next group, that is 14th group. You have carbon, silicon, germanium, tin and lead. Carbon family 6, 14, 32, 50, 82, these are the atomic numbers. These are the atomic numbers. Electronic configurations. Instead of 1s2, we can write helium, 2s2, 2p2. This is neon, 3s2, 3p2. This is argon, 3d10, 4s2, 4p2. krypton 4d10 5s2 5p2, xenon 4f14 5d10 6s2 6p2. So the general configuration is general outer configuration is ns2 np2. That means 4 valence electrons. Because of these 4 valence electrons, carbon exhibits +4, silicon also +4. When you come to the last elements, +2 and +4, here the lead shows +2 only due to inert pair effect. Due to inert pair effect. So why +2 is more dominant in lead? Due to inert pair effect. There is one question in the previous exams we already discussed earlier, but I repeat. PbI4 does not exist. PbI4, lead tetraiodide. It does not exist. Even if you form it, it immediately breaks into PbI2 plus I2. Most important this point. Why PbI4 does not exist? Because in PbI4, lead is in +4 state. Lead always want to be in +2 state. So it undergoes decomposition or it undergoes reduction from +4 to +2. The I minus undergoes oxidation. So why PbI4 doesn't exist? Because Pb in +4 state is a strong oxidizing agent and I minus is a strong reducing agent. So here two are side by side, a strong oxidizing agent and a strong reducing agent. They undergo mutual redox reaction and form PbI2 plus I2. So which is a strong oxidizing agent? Pb +4. Any element in its highest oxidation state is a strong oxidizing agent. Why KMnO4 is a strong oxidizing agent? Because Mn is in +7 state, the highest oxidation state. Why K2Cr2O7 is a strong oxidizing agent? Cr is in +6 state. So any element, if it is in its highest oxidation state means within bracket group number, it always acts as a strong oxidizing agent. Any element which is in its lowest oxidation state, which is within brackets group number -8, any element which is in its lowest oxidation state. What is that lowest oxidation state? Group number -8. Always acts as a reducing agent. Any element is in intermediate oxidation state. If any element is in its intermediate oxidation state, It can act as both oxidizing and reducing agent. These three fundamental important basics in the redox reactions chapter. Redox reactions chapter, you learn these 3 points. Okay, listen all of you. You only. Both of you, get up, go and wash your face and come back. Don't you feel shy in sleeping morning hours? Get up. You also. Both go and wash your face with cold water 10 times and come. So students who are feeling sleepy or drowsy, don't worry. Just go and wash your face. Have some muscular movement. So your muscles move, you take more oxygen and become again alert. That you have to do on your own. Don't allow the sleep, invite the sleep, and try to make a fortress of books before you on the bench. Behind the fortress, you are just hiding and sleeping. So all these techniques we know, we are in the teaching field for a pretty long time. So all these we know. So you have to avoid that. So after all, we are in the month of November. Somebody is writing here, days. 177 days are left. So only 177 days. Means 5 months, approximately. Or 6 months, no, 6 months is too much. Okay, if we add 3, 180 days, 6 months, okay. Positively 6 months. So these 6 months only you have to do wonders. You have to revise the things repeatedly, but you are not doing. Still lagging. So do. Revise the things. Be active. Automatically the result will follow. Because by God's gift or your nature's gift or your state's geographical location, here you need not get the marks as other students of South India gets to get a medical seat. Here relatively almost 100 marks less. 2024, what is your cutoff mark in NEET? 450?
469 for general, 569.
569 for general category. But mostly you are reserved, no? You talk only reserved. Mostly you are reserved categories. In the reserved category, 2024, what is the cutoff mark? For tribes, 467 is the for tribal people. Very easy task. And for if any scheduled caste students are there, the marks will be more, maybe 520 or like that. I think there is no backward communities here. If at all, if any tribe or scheduled caste to increase their social status, So the Christian missionaries will convert them into Christians. Then you will be converted into BCC. Almost it is a forward caste. Only 1% reservation. So, though you have a religious belief, that is not a problem. But changing your religion, caste, you are going to lose all the constitutional benefits given by the Constitution. So if you have reservation, please keep it alive. Don't kill it. Because it's not only useful now. After you becoming a doctor, you can go for civil services. You can become an IAS, IPS officers. Then also reservation plays an important role. Okay? That already your parents will be taken care of. We need not explain. So here relatively the target is a moderate target, not a heavy target, which in these 6 months, what are the past, leave it. These 6 months you are alert, focused, with confidence, you will easily, definitely will become doctors. So for that you do a proper way of work. So proper way means all the chapters taught in the class must be periodically revised. Without revision, you can't remember all the things. So that's why I asked what happens if aluminum react with nitric acid. You forgot the passive nature. Aluminum and beryllium, they are two diagonally related. We discussed in the periodic table, diagonal relationship. They show some similarities. Even now I can ask one more similarity. What is not beryllium, boron and aluminum, sorry. Boron and aluminum. No, beryllium and aluminum, sorry. Beryllium and aluminum, they are diagonally related. Second group beryllium, third group aluminum. Both form covalent compounds. Both oxides are amphoteric. Beryllium oxide is amphoteric, aluminum oxide is amphoteric. Aluminum carbide on hydrolysis liberate which gas? It is there in your notes, I will show it now. Beryllium carbide and aluminum carbide, both on hydrolysis liberate methane. That's why they are called methanides. So it is there 100%. You can check in the periodic table. Last topic is diagonal relation. In that it is there. It is there. Please read.
Beryllium carbide and aluminum carbide both on hydrolysis use methane gas. Because of which they are called methanides.
Because of which they are called methanides. So Frank, how many are able to recollect this? No. Why? Because long back, it is human nature. Long back we came across, but now passive memory, we forgot. That's why repeatedly I am telling, you should have your own plan to revise the things. Otherwise every day you become fresh. No sir, my brain is a black body, a perfect absorber and a perfect emitter. Today I absorb perfectly and today evening I perfectly emit. Now totally it becomes free. I don't want to hold the things in my brain. Brain become heavy. No. Human brain never become heavy, never be burdened. It has infinite powers. Human brain has infinite powers. Only we are using less than 1% of the powers. Because we are going in a routine, we don't concentrate how much powerful is our brain. In a routine we go. That's why A, a video game player got this year Nobel Prize in Chemistry. This year Nobel Prize in Chemistry has not studied any chemistry. In the childhood days, he is a prolific video games player. He is go on playing games and he want to create new games. He is mad behind video games. So that makes his interest towards computers, gaming and all. And he chose that subject. And he excelled well in that gaming platform. Because of his skills, he was employed in Google. Now he is a software engineer in Google. He knows how to play with the computer. He is able to build 3D models because he's a game expert. This 3D model expert, he converted his knowledge to protein molecules. Proteins are building blocks. They have three-dimensional structures. You study primary structure of protein. What is primary structure? Whether glycine is linked to alanine or valine or leucine or cytosine. So the sequence of amino acids linked to form a protein chain, a peptide chain, is called primary structure. So primary structure is nothing but sequence of amino acids. If you are eating groundnut, it contains Arachis hypogea, leguminaceae. That peanut contains arakin, a protein. So in arakin protein, how the amino acids are linked sequence, it has a particular sequence. That is called primary structure. If you take the saliva of a snake, which is nothing but venom, snake venom, it has a particular sequence of amino acids. It's a protein. The venom of a snake is a protein. When it bites, that protein enters into your body, blood system. So that protein may break all other proteins of your blood. It may hit the respiratory proteins of your blood or cardiologically located proteins. So some snake venoms immediately stop the heart. Some snake venoms cause total collapse of the respiratory system. So this protein injected by the snake, it's called venom, into your body, that has multiple effects. Or because of fear we may die. The snake is non-poisonous, but people die because of snake bites, because of fear. Though if a non-poisonous snake bites. But in the earlier Indian system, people used it to practice some mantra. Mantra is nothing but sounds. They used to practice certain sounds which have certain frequencies. So whenever a snake bite occurs, there are no anti-venoms at that time. In every village, one specialist will be there who is treating this disorder. So he will utter some sounds before that victim. So these frequencies will go and break the protein chain of the venom. And then it becomes non-poisonous. That requires a lot of practice and self-resistant. They should not accept money. Today they have given this type of treatment and a person survived. They should not accept money. They are not greedy. They should maintain certain rules and regulations. That's why those days they are very powerful. Their sounds are powerful. Their frequencies are powerful. That's why they are used to function in those days. But as we are modernized, these systems have collapsed. People don't believe also. That's why nowadays all primary health centers are provided with anti-venoms. I don't know your state. I go to Mangalore, it is richest number of cobras. Mangalore in Karnataka, highest number of cobras there in India. Everywhere cobra. And people won't kill it. Religious sentiment. They treat it as a god, snake god. So they never kill. There is a government cobra breeding center also in Mangalore. Okay, that is a different story. I am telling the proteins, our primary structure is sequence, secondary structure is coiling the peptide chains. In tertiary structure, further coiling. In quaternary, overall three-dimensional geometry. So under 4 headings, we study the protein structure. Because from one structure to second structure, second to third, third to fourth, the complexity increases. It becomes more and more complex. You can't visualize a protein unless otherwise you have a 3D picture. This year Nobel Prize winner, he created different 3D models, millions of 3D models for different proteins, which makes the doctors, scientists to understand exactly what is protein, what is clearly, how to treat that protein. So he made an elaborate study on proteins because he knows only building the 3D structures by using computer. Nowhere he knows any chemistry. So the extraordinary powers of brain. You can become anything. You can become a burglar, you can become a murderer. You can become a thief. Whatever way you can want to, you can become like that. But nowadays, hopefully, we expect you to become doctors only. Okay? Now, carbon has highest catenation power or catenation power in the periodic table. So, catenation power is directly proportional to bond strength. Catenation power. Strength of the bond. You know, carbon-carbon single bond strength, 83 kilocalorie per mole. So they are asking this question, E carbon-carbon bond is stronger than E silicon-silicon bond, E germanium-germanium greater than bond energy of tin, bond energy of lead. This is the decreasing order of bond energy. It is the same decreasing order of catenation power also. So catenation power and bond energy are directly linked. Here I mentioned E means bond energy. When bond energy decreases, automatically the catenation power also decreases. So regarding the allotropes of carbon, almost 4 to 5 points we have to mention. The allotropes of carbon can be divided into 2 types. Allotropes of carbon, crystalline, amorphous. Crystalline, you have diamond, graphite, carbon 60, Buckminster fullerene, amorphous you have coal, coke, wood charcoal, animal charcoal, sugar charcoal, gas carbon, lamp black, petroleum coke. So altogether 4-5 points are there for examination. In diamond, carbon atoms are sp3 hybridized. It has a 3-dimensional arrangement and one of the hardest substances known. So if diamonds are properly cut and polished, they have very valuable market value, gemstones. They become glittering if when present in the light due to total internal reflection. The CC bond angle in carbon diamond is 109 degrees 28 minutes because it is sp3 hybridized. Impure diamonds are used for cutting the glass because diamond is a natural abrasive. Abrasives are very hard substances. So these are all the points related to diamonds. Students should know about sp3 hybridization, abrasive material. It is an abrasive. Regarding graphite, carbon atoms are sp2 hybridized. It has a 2-dimensional layer lattice structure. What is the structure of graphite? 2-dimensional layer lattice structure. In graphite, each carbon is left with 1 electron, free electron. And these free electrons makes graphite as conducting. In graphite, free electrons are conducting. That's why graphite is used for making electrodes. We already discussed lead pencil. Do not contain any lead. It is a mixture of clay plus graphite. Since lead marks on the paper, graphite also marks on the paper. We call the pencil as lead pencil, which do not contain lead. It is a mixture of clay plus graphite. So graphite is also used for making refractory crucibles. Refractory crucibles means it won't melt and makes others to melt. Thus, if you want to melt any metal, you take a graphite vessel and put the metal in that heat. Metal melts, graphite won't melt. They are called refractory materials. So carbon 60 Buckminster fullerene. So it is also one of the crystalline allotropes of carbon. In this, here one important point is there. Here one point. Here one point. 3 points. First point regarding wood charcoal and animal charcoal. Highly porous, they are highly porous and used as adsorbents. To remove the color of sugar in sugar industry. Used as adsorbents to remove the color in the sugar industry. Gas carbon is a conducting allotrope used for making electrodes. Just now we discussed Hall-Héroult process. Lamp black is used for making carbon papers and boot polishes. Lamp black for making carbon papers and boot polishes. Petroleum coke is used for making electrodes. This is regarding the allotropes of carbon. Next. Another important point is CCl4 does not undergo hydrolysis, while SiCl4 undergoes. This is a very important point. Answer: in CCl4, no available vacant d orbitals. In SiCl4, presence of vacant d orbitals. This is the reason. Suppose if you take SiCl4, it has a d orbital, because silicon configuration I already wrote in the first slide. 3s to 3p2. So after 3p, 3d is available. 3s, 3p only occupied with some electrons. 3d is vacant, available. Now this available d orbital, when treated with water, hydrolysis means water. So water molecule always act as Lewis base. Any molecule with vacant orbitals act as Lewis acid. So it donates an electron pair here. So it becomes SiCl4 times OH2 plus. Why O become O plus here? Because it donated electron pair. So finally, one of the hydrogen gives its bond pair, and one chlorine also want to go out in the form of HCl. So we will get SiOH plus HCl. So each step the process repeats. Next time one more chlorine, like that, finally. In each step water molecule attacks. So total in the 4 steps. Whenever water attacks, which is removed and which is occupied? Cl is removed, OH is substituted. So what is the final expected compound? SiOH 4 times. What is the final compound? SiOH 4 times. Or which can also be written as H4SiO4, which is called orthosilicic acid. So in the 14th group of P block, this is one of the important questions. CCl4 does not undergo hydrolysis, while SiCl4 undergoes. What is the reason why CCl4 is not undergoing? Due to non-availability of vacant d orbitals. Why SiCl4 is undergoing? Due to the presence of available vacant d orbitals. So whenever a particular molecule is undergoing hydrolysis and every step HCl is liberating, this HCl liberates, gives fumes. SiCl4 fumes in moist air. We keep in a watch glass some silicon tetrachloride. It go on giving fumes because it is undergoing hydrolysis and liberating HCl. Write that point. SiCl4, AlCl3. SiCl4, AlCl3 fumes in moist air. Fumes in moist air as they undergo hydrolysis. As they undergo hydrolysis and liberate HCl. In the next point, in the carbon family, if you take oxides, carbon has 3 oxides: carbon monoxide, carbon dioxide, carbon suboxide. Silicon has only one oxide, Si wood. Germanium dioxide. Tin has 2 oxides, SNO, SNO2. Stannous oxide and stannic oxide. Lead has plumbous, plumbic, a mixed oxide called Pb3O4. Pb3O4, a mixed oxide. It is also called red lead. Pb3O4's common name is red lead. Now this is the only neutral oxide. Neutral oxide. These two are acidic. This is acidic. These are all amphoteric. So what is a neutral oxide? It is neutral towards litmus. Already discussed in the periodic table. Again, if you see the classroom notes, you will find this. Carbon monoxide is a neutral oxide. Neutrality means neutral towards litmus. Now, in carbon monoxide, carbon with 2s2, 2p2, and oxygen with 2s2, 2p4. These two must combine to form carbon monoxide. one C and one O. So how this combination occurs, we already discussed, but again I am repeating. The two unpaired electrons of carbon, two unpaired electrons of oxygen, they form a double covalent bond. Or Lewis dot structure. You can write two pairs. This is initially what we expect. Two unpaired become two pairs. And the pairs are shared equally. That can be represented like two normal covalent bonds. Now there is a back bonding here. The lone pair present in oxygen is back donated to the vacant orbital of carbon. So here, this back donation occurs. That's why carbon will have 3 bonds with oxygen. And a donor gets plus, acceptor gets minus. Oxygen is the donor, carbon is the acceptor. So this is the structure of carbon monoxide. It is very strong ligand. Strong ligand. Or perhaps it is the strongest ligand in the spectrochemical series. In your coordination chemistry chapter, you have crystal field theory, CFT. The crystal field splitting depends on the strength of the ligand. So in your NCERT textbook, an order is given, strength of ligands, which is called spectrochemical. Nickel plus 4CO, nickel tetracarbonyl, Fe plus 5CO, FeCO 5 times. These are called metal carbonyls. In metal carbonyls, the oxidation state of metal is 0. Nickel carbonyl is tetrahedral. It is a tetrahedral. This is trigonal bipyramidal. This is octahedral. Here sp3 hybridization. Here sp3d2 hybridization, sp3d. Here sp3d2. Again, you will study in D and F block elements about these carbonyls. Now the next point, carbon monoxide combined with chlorine in the presence of sunlight form carbonyl chloride, which is also called phosgene, a poisonous gas. CO plus 2H2, CH3OH. Here Fe2O3 plus ZNO. act as catalysts. This is how methyl alcohol is made synthetically. Very important point. Another important point, the most important point, even in the future if you write civil service exam, carbon monoxide is the most important reducing agent in iron and steel industry. So Fe2O3 plus 3CO, 2Fe plus 3CO. This reaction occurs in the blast furnace in the extraction of iron. So in the extraction of iron, what is the important reducing agent? Carbon monoxide. Though initially we add coke, finally the reagent is carbon monoxide. So carbon monoxide, as you know, it is the most dangerous gas, colorless, odorless, tasteless, poisonous gas. If human beings inhale carbon monoxide for 5 to 10 minutes, death occurs instantaneously. So CO is one of the most poisonous gases used to kill the living organisms in mass numbers, huge. When you want to kill huge, eliminate huge life on the planet Earth, the most sought after gas is carbon monoxide. Because when bird flu hit China, the chicken comes to China from Hong Kong, which is also a Chinese country. So Hong Kong, Chinese government want to totally eliminate the poultry from Hong Kong. Because which bird is affected with the virus? Bird flu virus. They don't know. They want to kill each and every bird. So the Chinese communist government ordered to kill the entire chicks in Hong Kong. So how to kill that many birds in few days? So what they choose is carbon monoxide. They used to keep the birds in big plastic bags and put a tube and a cylinder, press some carbon monoxide. Within 2 minutes, all birds will die. Like that, they totally eliminated the poultry 10 years back. And they grew new poultry, free from virus. Because every time they can't check each and every bird, whether it is affected by virus or not. So Chinese take some decisions like that. Sometimes they are productive, sometimes they are highly non-productive. Like that Mao, the foolish Mao, they call China as like Mahatma Gandhi in India. Chinese worship Mao as their father of nation. Cultural revolution. So Mao is a hardcore communist. One day he asked his agricultural scientist, how many food grains, paddy, rice grains, is eaten by sparrows? So a Chinese scientist calculated each sparrow per day how many grains it can eat. In a total harvest time, how many grains they eat, total sparrows of the country. They made an elaborative study and this many millions of birds, this many grains, total this much food grain is lost every year. In China, only birds are eating. Then he asked, kill all sparrows. And he announced a reward. For each sparrow you kill, you will get this many yuans of money, Chinese currency. So Chinese people have nothing to do. They used to take big steel plates and hit them with a wooden rod. Big sounds come, sparrows will fly, and they will again take rest in another tree. Again, one more group of people are there. They again make sounds. They again jump to another tree. Like that 3-4 times. They can't, they'll exhaust their energy and fell down. And they used to kill them. And take those sparrows to the nearest center. Today I killed this many sparrows, this many you wants. Mao thought he is very intelligent, saving a lot of food grains, because he totally eliminated all these sparrows from Chinese mainland. That made a great ecological imbalance. That fool, he thought he had done a great job saving so much of food grains. The ecological imbalance in China is so huge. There is no cross-pollination by insects and sparrows. It's all called ecology. This ecological imbalance caused a big famine in China that causes so many billions of deaths, human deaths. Earlier he killed sparrows, now he killed his own human beings. Chinese people don't have food grains to eat. Total famine, drought. Then what they used to do, they used to kill whatever the animal present on the earth and eat. That's why they used to eat cockroaches, frogs, monkeys, snakes. In China, why the people eat all animals present on the earth? Because of this one. They are called wet markets. They eat bats also. You know, bat is a mammal. These bats are the main reason for the COVID-19. In the wet market of Wuhan province of China, where the first COVID cases were reported, because of Mao long back, people have developed eating every animal. So in Javanese, they eat dogs also. Even in India, Nagaland, people eat dogs. So, which is border of China. Anybody is here from Nagaland? Because Nagaland street dogs are rare now. Because if any dog comes, they will catch and kill and eat. If you see the Beijing Olympics menu, food menu, assorted scorpions. Scorpions are roasted and kept in big plates. Assorted scorpions. Monkey heart soup. Monkey brain fry. This is the menu of the Beijing Olympics. Cockroaches dry fry. So because of Mao only, they developed eating all the insects, animals. Because at that time famine is there. People have to survive. So they kill and eat. And that became a routine. So on the planet Earth, they kill each and every animal and eat. So that culminated into COVID-19. See, if you do harm to the environment, that will take a revenge on you. Unexpected, huge revenge. Even you can't do anything. You become helpless. In COVID-19 time, people are just indoors, closing all the doors and fearing what happened next day. How many will survive, how many will die. So actually our flight was booked at that time We landed in Dubai, Dubai to New York. New York airport, only we two are there. Nobody is there. We want to take coffee, no, all close. No restaurants, nothing. Only we two people are there from India. 10, 15 Americans are there. We have to travel from New York to Austin. Horrible. Even we are also doubtful whether we reach or die because of cough and cold. After all, it is virus only. People die in large numbers because of fear complex also. So whenever fear is there, your immunity decreases. You know that? If you are strong, if your willpower is strong, nothing can happen. COVID virus can't do anything. We are teaching at Mangalore at that time. They asked us to bring a fresh report of that test, COVID test. So every time when we are going to the airport on the previous day, we will have a test, 1,000 rupees test, and the report comes. So that is again checked by the net because that Aadhaar card is linked. So 3-4 times I am COVID negative. I traveled and taught and came back. 5th time I got COVID positive. COVID positive, no symptoms. No cold, no cough. Smell is there, taste is there, everything is there. No fever. But officially in a good laboratory it came positive. Already we have to go and teach 10 days there. So then one of my friends suggested, no, there is one agency. They will do some fake test. They won't do any test. They will take our Aadhaar and they will give a negative report on that. So I said, better. Because no symptoms. So, but cost is double, 2,000 rupees, okay. And compared to 10 days, our earning 2,000 is nothing. And cross-check also, we are pakka because our Aadhaar card is linked to that test. So first test, which positive, we teared off. Second test is negative, fake negative, with no symptoms. Because we are also there, because no symptoms are there. Asymptomatic. Like that. So this virus is also, actually COVID virus is there or not there, still a question mark. Whether really it is there, whether it is really not there, whether the vaccines are there, really functioning. We took only 3 vaccines and we kept calm in India. In US, every month 2 vaccines. People are go on taking vaccines, COVID vaccine only. Every 2 months they are taking vaccine, like a normal crocin tablet, they are taking COVID vaccines. Means their immunity levels are so low. Repeatedly they should be activated by vaccines. And these vaccines, messenger RNA based vaccines, whether they are safe or not, a big question again. So finally it became a mystery now. Some people say it is there, some people say it is not there. Doctors don't know what to do, protocol, how to treat. How to treat COVID, initial doctors also don't know. Which medicine they have to give? Favipiravir, one injection came. This favipiravir should be given in the beginning or middle or at the end, they don't know. Initially they go in the beginning, people died. Like that. Okay. So sometimes it happens like that. One more important property for carbon monoxide. Most important, right? Most important. I think I taught you in Bangalore. No, Bangalore I taught, okay. The best reagent to detect and estimate carbon monoxide is Fe2O3, iodine pentoxide. So Fe2O3 plus 5CO violet vapors. Because carbon monoxide is a colorless, odorless, neutral oxide, poisonous nature, you can't smell it and say it is carbon monoxide. So the best reagent, whether the given gas, if I give a small vessel or a jar enclosed, closed with a lid, inside carbon monoxide is there. So I asked you to identify whether the gas present in this is CO or not. You put a litmus paper, blue and red, in moist condition, color is not changed. So you say it is a neutral oxide. Of course, carbon monoxide burns with blue flame. It is a combustible gas. It is a combustible gas. It burns with blue flame. But many gases burn with blue flame. Methane, ethane, butane. Most of the hydrocarbons burn with blue flame. So by flame color also you can't identify. So what is the best reagent? You add some iodine pentoxide, Fe2O3. Immediately violet vapors of iodine are liberated. The given gas is carbon monoxide. So what is the best way to identify or to estimate how much amount is present? That is iodine pentoxide. So the only reagent in our syllabus to identify carbon monoxide is iodine pentoxide, very, very, very important. So it is a reducing agent, we already discussed. We already discussed that point. It can be prepared by reducing CO2 plus red hot coke to CO. This is CO preparation. Preparation of CO. Regarding CO2, CO2 has a linear structure. Its dipole moment is 0, non-polar. You can write a resonating structure like this. Then you will get a triple bonded O here with O plus, single bonded O with minus, or it can be resonating like this. this side O minus, this side triple bond O plus. This carbon dioxide structure. So when double bond of oxygen shifts, carbon become plus. Now because of this, carbon is becoming positive. It acts as an electrophile. So carbon dioxide is an electrophile. Now CO2, when passed through lime water, it turns milky due to CaCO3 formation. CO2 turns lime water milky. CO2 electrophile were used. CO2 electrophile were used. Anyone in organic chemistry? Which one? CO2 electrophile we use in organic chemistry in our syllabus. Kolbe-Schmitt reaction. Phenol plus CO2 plus NaOH gives salicylic acid. So right there itself within the brackets. CO2 electrophile is used in Kolbe-Schmitt, SCHMIDT, Kolbe-Schmitt reaction, where phenol is converted into salicylic acid. Where phenol is converted into salicylic acid. With NaOH and CO2. With NaOH and CO2, carbon dioxide. CO2 plus H2O, H2CO3, carbonic acid, which is called a soda water. All aerated drinks contain this. Or carbonated drinks. CO2 is a gas, while SiO2 is a solid. This is a very important question. Both carbon and silicon belongs to same group. Carbon dioxide is a gas. SiO2 is a solid. The reason is due to difference in their structure. Difference in their structure. CO2 is a double bonded molecule, which is a discrete molecule, separate molecule. Discrete molecular structure. But in SiO2, silicon is tetrahedrally bonded with oxygens. And the structure go on repeats.